Good morning. So this is a very important numerical for rotational collision and gives you a perspective on how the law of conservation applies when it comes to rotational motion. So you can see there is a disk which is at rest, and there is a disk which is rotating with omega a1 on the left hand side, which refers to before. Now, this disk, which is at rest, comes and sticks to the second disk down below. And then the combined disks, disk number one and disk number two, which is A and B, they combine and they start rotating. Now, the question is, what is the new angular velocity of the combination of the disks? Now, if you see on the left hand side, the initial angular momentum is only because of the disk A and is given by I into omega. And since there is no external torque, the total angular momentum has to remain conserved. So the new angular momentum after they stick with each other is IA plus IB into omega 2, where IA and IB refer to the moment of inertia of the disks, and omega 2 is the combined angular velocity of the system. Apply the law of conservation of angular momentum, equate the two, and you can find the angular velocity of the combined disks. So this is an example where one disk collided with the other and got struck. This is a case of inelastic rotational collision.